Just a little segment I'm going to be calling Cruise the Cosmos. For those of you who don't know me, my name is Joshua Laughlin. And I wanted to, I really want to say thank you for allowing me to talk with you. I don't really do too many talks in public, so I really appreciate the opportunity to be able to talk to you tonight. Next slide, please. As before, if you hold up any questions, any comments, that would be great. We'll try our best to discuss at the end of this presentation. But, yeah, next one. Okay. Stars, Life and Death, Part 1. And the reason it's Part 1 is because there is no way to take everything there is about stars and try to cram it into 15 minutes. It's what caused Cruising the Cosmos to become what it is. We were trying to figure out how we could do it, and there isn't a way. We had to break it up. So what questions you have, what comments you might have, understand that there's going to be multiples of these, and we're going to do our best to cover everything for you. So we're going to say our star, the sun. I would like to believe that everyone knows that our sun is a star. However, if you see here what looks to be a Facebook post, someone tried to convince me that the sun is a star. The sun is a something. It's a sun. Okay? Boredom. My professor said the sun is a star. What an idiot. My teacher is so dumb. He thought the sun was a star. And this goes to show you that there are people who don't realize the sun is a star.
The sun is a sun.
So any of y'all that have actually looked at the sun, well, I would like to believe that most people don't. If you have kids, I'm sure you've probably told them, don't stare at the sun. You also might want to elaborate and let them know that even if they try, they're not going to be able to see what it really looks like. Maybe if my mother would have told me that, I wouldn't have to wear contacts now. We see in the visible range of 4,000 to 7,000 angstroms, roughly. You see here visible light waves and ultraviolet. Ultraviolet being 4,000 to 10. We have X-rays 10 to 0.1 and gamma rays less than 0.1. The reason I'm pointing this out is for this. This is what most of y'all probably seen through y'all's telescopes. It's seen with 4,500 angstroms. However, this one, and this one are an ultraviolet. This is a composite picture of our sun with multiple wavelengths of ultraviolet. You can see wonderful activity all across the sun. Another composite picture of the sun, just demonstrating further activity. I want to say this is from early this month, showing that stars are very active. I believe many of us know that, but it just shows, if you see here, this right there, the sun, you can watch all of that material being blown out. So stars come in various sizes. That right there, which the pointer is actually larger, is our sun. And you can see the varying degrees and sizes of all these stars. For anyone who doesn't know, Betelgeuse and Orion, the right shoulder of the constellation of Orion. VY Canis Major, which I believe is known as the largest known star, somewhere in that little box is this, our sun. This is trying to give you an idea of the different sizes and how large things really get out in space, even though this is kind of cut off. It's okay.
I don't know why I did that. I'm sorry.
It's okay. So right here we got Jupiter. And there's Jupiter again. You can see our sun, and just all the way down till you get to VY Canis Major. So how are they created? Well, from things like this, the pillars of creation, nebulas. This is the Orion Nebula, host to many, many new stars. When something like such as a supernova causes the gases to shift, it allows gravity to take hold. Once it takes hold, the gases will start to compress. They'll get hotter, they'll start spinning. The protostar will start to ignite. The fusion in the protostar will begin at roughly 10 million kelvins, which is 20 million degrees Fahrenheit. This is a diagram showing exactly how that process is created. The whole process takes roughly 50 million years or so. I believe that's what they said. What is the difference between a star and a planet? A lot of people believe that Jupiter is a failed star because it's got hydrogen and helium. Same stuff that's in most stars. The problem with that is a star is created from the gases collapsing in on itself. It's at the center. Whereas the planets are the leftovers. It's all the material on the outside. That's the major difference here. And we're going to just roughly touch on this real quick. The life cycle of a star. You got your nebula, still a nebula. Your average star, such as our sun, red giant. Once the red giant burns its fuel, blows it off, becomes a planetary nebula. What's left over is the white dwarf. You got your massive star, red supergiant. Supernova becomes a neutron star or a black hole. Our sun should go red giant in roughly 4 billion years. That's give or take. Once it does that, it could engulf the Earth. We don't know. We don't exactly know what's going to happen there. It's just a prediction. But it's going to happen when the hydrogen is burned up and it's left with the helium. When it blows it off, it forms the planetary nebula. This is the Cat's Eye Nebula. Center there would be your white dwarf. And all that material will give way for new stars. However, once you get to the larger stars, the more massive stars, they burn further elements, the process known as nucleosynthesis. And they go all the way down, depending on the mass of the star, to create iron. Another chart demonstrating the elements being created in the stars. When massive stars die, they become supernova remnants. And this is the Crab Nebula. Stars create all the elements you see around you, well, besides hydrogen, helium, and any man-made element. This is just a periodic table of the elements, just to demonstrate that what's created in the stars is on there. It's everything that they do. They're factories. the point of this is just to demonstrate that what you are, everything that's inside you, was built inside stars. They died so we can live. So when you look around you, look at the people around you, you can see how different they are to you. Look at the chairs, the tables, the telescopes. It's nothing like you at all. But the elements, they were formed inside the stars. We're all linked together. Something that's very interesting is the fact that the elements, let's say in your feet, could be from one star, whereas the elements in your hands could be from a completely different star. It's not just one star, it's multiples everywhere, creating everything you see. If you wish to make an apple pie from scratch, you must first invent the universe, from Carl Sagan. And he's basically saying that the carbon that's inside that apple pie is from stars. We are star stuff. So this is just a basic. I want to cover basics. I understand it's very, very short, very brief. It's not a whole lot of detail right now. But that's because in the future I would like to be able to cover it. I wanted to make sure we actually discuss the different types of stars. The red giants, the white dwarfs, even down to the brown dwarfs. I want to cover the stellar classifications and the different types of deaths there are with each star. So basically, when you think of the stars, don't really think of them just as bright, luminous things in the sky. Think of them almost like family. Think of them as your fathers,